And also about 100 or 80, 60 years ago, companies had a VP of electricity, the type, or VP of energy for the company to optimize and I feel like we're moving back towards those trends. A lot of DC production happening behind the meter, behind the transformer on the side of the consumption, and also a lot of like optimization opportunities are going to come with that. And so we're going to have like mini managers or maybe VP managers of energy, and
Hmm.
large companies like the big tech companies obviously have huge departments that deal in that. But I
Oh
think
yeah.
that might become a more common thing even for medium-sized commercial and industrial assets.
No, I completely agree with you. Yeah, I completely agree. I mean, it's you can save so much money by, putting a little bit forward, essentially,
Yeah.
is what we've noticed. And you also have those scenarios though where like the grid, we all know that the grid isn't what it used to be, is a good way to
Yeah.
put it. It's
Yeah.
just not
Yeah.
able to provide the power that everybody necessarily needs. So we're even seeing that like from these electric providers where they're starting to install some of these large PV array fields with batteries. So that way their old transformers that they have, which have been getting overloaded for these towns, they're not having to put the stress on them that they used to, because you can
Exactly.
interconnect, on the secondary side, right? Going straight
Oh,
to, yeah, yeah,
so
yeah, yeah.
bypassing the old transformer, you mean?
So essentially, yeah, you're injecting power to take the load away from that transformer. Yeah.
But you're
Yeah.
still going through that transformer when you inject the power, right?
Well, okay. What I'm talking about is from their power plant, right? You have your transformer that's, say you have one that's shooting out 34.5, right?
Yeah.
Well, we can come in and we can plop our battery system and our PCS unit down there. We can connect to that 34.5. So then that transformer that's at the power plant isn't
Yeah.
having to take all that load, because we
Yeah.
can
Yeah.
we can
Yeah.
inject
Got it.
you see what I'm saying? Yeah, yeah,
Yeah.
yeah. So that's another thing that's been happening. Just
Got you.
so, I mean, it's so expensive to put in new equipment everywhere, and I mean, running
Right.
highline wires is not cheap. So
Right. Yeah.
I mean, that's another scenario that we're seeing a lot of, which those ones are fun. I mean, they're
Yeah.
they're bigger scale. So, uh, but yeah,
Yeah. So
that's
I
stuff
guess
all over
we're
the
in
place.
agreement that a lot of production growth, I think, is going to happen on the other side of the transformer and the meter as
Oh
we
yeah.
move into this century. And so what other application, like what other settings are you seeing this demand in, like besides factories? um, CNI in California is a whole other story, obviously.
Mhm.
Are you seeing in other geographies? You mentioned some of the flyover states being
Yeah.
overloaded, and
Yep.
um,
Yeah, so
uh,
and yeah, Midwest, like I said, that so you actually seen a large influx of people moving there. And like, even, I don't know if you consider Texas a flyover state, but even Texas, maybe parts of Texas, I can tell you Lubbock, you can just fly right over that place.
Texas
Um
is the number one solar state now, I think,
it
right? Or
is, man,
number
it
two, if it
is.
is not
It
number
is.
one. Yeah, yeah,
Um, um, yeah, so if you group Texas into that, like I was saying before, you've gotten to where all these people have moved to these new places, and the amount of people requiring power there has increased so much that the existing systems just can't handle everything. So
yeah,
that's where we're coming in, and we're supporting these utilities by installing these massive PV farms with battery systems to capture some of that excess PV whenever maybe the demand's not quite as high, but it's still pushing power. And then that best unit can discharge at some of those peak times later in the afternoon. That's a big